Ever pondered the marvel of flight? How does a sparrow dart through the air or a Boeing 747 jet across the sky? Today, we dive into the captivating world of flight mechanics, from the wings of a bird to the engines of a rocket. First, consider the bird. Birds have mastered the art of flight through evolution, their bodies perfectly designed for this purpose. They achieve flight through a delicate balance of four forces: lift, weight, thrust, and drag. Lift and weight are vertical forces, with lift opposing the bird's weight. Thrust and drag are horizontal forces, with thrust propelling the bird forward and drag resisting this movement. When these forces are balanced, a bird maintains steady flight. Birds generate lift by flapping their wings, the unique shape creating a pressure difference between the top and bottom surfaces. This pressure difference lifts the bird into the air. Thrust is produced by the down and forward motion of the wings. By adjusting the angle and speed of their wing flaps, birds can control their flight speed, direction, and altitude. Moving from the natural to the engineered, we turn to the airplane. Like birds, airplanes rely on the same four forces: lift, weight, thrust, and drag. However, they generate these forces differently. Airplanes produce lift with their fixed wings, using their shape to create a pressure difference, much like birds. But instead of wing flapping, airplanes use engines to generate thrust. The engines push the airplane forward, the air resistance creates drag, and the weight pulls it down. When these forces are in balance, the airplane flies. Next up, helicopters and drones. These machines fly by spinning their rotors or propellers, which work like wings. As the rotors spin, they create lift, allowing the helicopter or drone to rise. By adjusting the angle of the rotor blades, these machines can move forward, backward, or sideways. They can also hover in place, something airplanes and birds can't do. Jet planes, a type of airplane, use jet engines for flight. These engines suck in air at the front, compress it, mix it with fuel, and ignite it. The resulting explosion pushes the jet forward. Jet planes can fly faster and higher than propeller-driven airplanes because jet engines can produce more thrust and work better at high altitudes. Finally, we delve into the realm of rockets. Rockets fly by expelling gas out of their engines in a process called rocket propulsion. Unlike other types of flight, rockets don't need air to fly. They carry their own fuel and oxidizer, which ignite to create a high-pressure and high-temperature gas. This gas is expelled through a nozzle, pushing the rocket in the opposite direction. This is how rockets can fly in space, where there's no air. In summary, flight is a balance of forces: lift, weight, thrust, and drag. Birds achieve this balance with their wings and bodies. Airplanes use fixed wings for lift and engines for thrust. Helicopters and drones use spinning rotors, while jet planes use jet engines. Rockets, uniquely, use rocket propulsion to fly in airless space. Each method of flight is a marvel of nature or engineering, a testament to the ingenuity of life on Earth and the human mind.